Listen. Again, like I said, if you have a curve, this is a curve, function f of x. At a particular point on x, let's say this point, we can draw a tangent to the curve. So let's say this is the point when x is equal to a. Okay? Then what we know is that we will find f prime of x, that would be the gradient function, the gradient function at any point, right? But if you find f prime of a, that gives you the gradient function at this point. And that is the gradient of the tangent. Okay? At x is equal to a. Of course, the gradient of the tangent at x is equal to a is the same as the gradient of the function at x is equal to a. Understand that? A normal is a line perpendicular to the tangent. So this line is the normal to the curve, while the green one is the tangent to the curve. So even if the problem is talking about normal, you begin by finding the tangent. The reason is, normal and tangent are perpendicular, as you can see. And you have learned in your IGCSE classes, when two lines are perpendicular, what do you say about their gradient? The product is -1. Do we remember that? It's time to refresh your memory. Do you know that, what we talked about? Kind of, okay. If this line has gradient 1, gradient m1, and this line has gradient m2, and they are said to be parallel, then m1 is equal to m2. Two lines that are parallel have the same gradient. However, if they are perpendicular, the gradient of this is m1, gradient of this is m2, we have seen so far that the product is -1.
Yeah. Because like this line is like
okay. So, what we are trying to do here, also, okay, maybe I put some recall. Let's put it down as fact to recall. This, take notes. I will answer all your questions here, Karen. So even if you don't remember or you didn't do it previously. But wait, you had the IGCSE class here, right? Okay. Fact to recall. 1. If line L1 has gradient let's okay, given, I don't want to erase it, but I have to erase it. Sorry. Let's M1 be the gradient of line L1 and M2 be the gradient of line L2. Then M1 equals M2 if L1 is parallel to L2. And the second, M1 times M2 is equal to -1 if L1 is perpendicular to L2. These are previous knowledge that we need to recall. Another fact that we will need here. If a line, or should I say equation of a line, there are different forms of finding the equation of a line, but only one is what we need, so I just focus on that. If a line L has gradient M, and it passes through the points x1, y1, then its equation is given by y minus y1 equals mx minus x1. Do we remember this? This is one of the forms. There are so many forms. Not like so many. There are different forms of finding the equation of a line. But the one that we need for this is this. Okay? If you can get the gradient of the line, gradient is how slope is this, right? To the horizontal. You can get the gradient and you can identify a point on the line. You can use the gradient point form to find the equation of the line. We call this gradient point form. That is, we know the gradient and we know one point. We have the 2-point form. We have the gradient intercept form. Gradient intercept form means you have the gradient and the y-intercept. That is y is equal to mx plus c. Because m is the gradient, c is the y-intercept. Okay? We have double intercept form as well. We don't need to go into all that. And 2-point form is another interesting one. So these are facts that we should recall. So when finding the equation of a tangent by calculus, the first thing we will do is to find the gradient of the tangent. Once we find the gradient of the tangent, we will also be given a point on that curve. And with that, we can find the equation of the curve. I will write some examples now. We will play with it together. I'll start with a simple function. Find the equation of the tangent to the curve y equals x cubed minus 5x plus 6 at 0, 6. Maybe I use 1. Let's use 1 minus 7. Is that 2? When x is 1, y is 2. Correct? Yes, that's 2. So, listen. Listen, please. So let's say this is the curve, for example. At x is equals to 1, let's say this is the point we're talking about. Clearly, there will be a tangent drawn to the curve at that point. I would like to change it to tangent and normal. Okay, so we can do 2 in 1. So the tangent is this, then this will be the normal to the curve at that point. Is that clear? So the first thing is we need to find the gradient at this point. So we start by finding our dy dx. This is 3x squared minus 5. Yes? So at x equals to 1, I told you can write like this. Remember that? It means the gradient at x is equal to 1. At x equals to 1, we have 3. 1 squared minus 5, which is negative 2. In that case, this is not the shape. The shape will go like this. Understand? Now, so the gradient of the tangent at that point is negative 2. And the gradient of this curve at this point is also the gradient to the tangent of the tangent to the point at that point. Do you understand what I mean? So you can say, oh, this implies that M1 is equal to, I call it M1 because I'm dealing with 2 lines now, tangent and normal. Alright? If you are dealing with only tangent, just use M, no substrates, 1 or 2. If you are dealing with normal, just use M also. No, for normal, you need M1, clearly, because you have to find the equation of the normal from the tangent. Anyways, so M1 is equal to this, you can put here gradient of tangent. Okay, then which implies that the gradient of the normal, or maybe we saw tangent first, okay, from y minus y1, m into x minus x1, this is the equation of the tangent. So this is the equation of any line whose gradient is known and whose points any point is known on the line. And because we said it passes through this point, that's our x1 and y1 clearly. Understand? So we substitute. So it means y minus 2, m negative 2, x minus 1. Karen, you want to get up? You're closing your eyes. Okay? Understand? So you can just write in any form that comes to your mind. Y plus 2x minus 4 is equal to 0. Some people might leave it as y is equal to 4 minus 2x. Your choice. Now, that is for tangent. Since the gradient of the tangent is this, then you can find the gradient of the normal. From m1 is equal to negative 2, it implies that m2 is equal to 1 over 2. To find the second one, if the product is negative 1, you flip it and you change the sign. Flip and change the sign. That's the easy way. You don't have to substitute, solve the equation, like, no, we don't need all that. Flip it and change the sign. So you do the same again. And y minus y1 equals mx minus x1 will imply that y minus, again, 2. This time around, 1 over 2, x minus 1. So we simplify this. I want you to bring out your computer. Go to decimals. Y minus 2, half x minus half. Declare the fraction, 4x and 2x. In decimals, put this curve, put this equation, and put the one I'm about to deduce. So put these three, the curve, this one. You can also get a point. I didn't bring my computer, I didn't think I was going to need it. You can also get a point in decimals. All you have to do is type 1, 2. It will give you an option of label. You can click on the label too. Are they tangent normal to themselves, to the curve, something? Wait, what's going on? Yeah, that's it. They put the point. Can you label the 1, 2? Bracket, 1, 2. Label, click label. Yeah. Can you take a screenshot of that, send it to the WeChat group? There's one more. 2y minus x equals 3. Click on this label. Yeah, you can even call it A or whatever, but I want you to move the coordinates. Aha, so that's it. So did you see that? Can you see the tangent, the normal? You want to look at this screen if that's not working for you? Is it working? Wait, where do you get x over 3? Where do you get x over 3 from? Tell me what's going on? There's x over 3. Huh?
That's probably
It's showing off the scale.
Oh, we're only looking at
Yes, it's 2. You can use 2y minus x.
Oh.
It's just showing off.
Oh.
It likes to show off. It's just saying, yeah, it's the same, I'm cool. That's what it's doing. Does this make sense? So, the same way we have done the algebraic function, you can have a logarithmic function as your y. Okay? You can have an exponential function. You can have a trig function the same way. So any function that you can plot to give you a curve, clearly you can find a tangent at a point, at a chosen point. And once you can find the tangent to the curve, then the question is, what is the equation of that tangent? That is what we are trying to do here. And similarly, we can do the same to normal. Okay? So we'll take one of the so-called tough questions. Let's say we use an implicit function now instead of a normal direct one. Yeah? Yay. Or maybe I ask you to try one first before I do the implicit. Is that okay? All right. Why don't you, after you write this, I need you to attempt question Oh, why did I put question 5? That is not the gradients to the tangent to the point is that to the p.
那你讲在哪个地方？gradient 在哪里？
啊
它带了进去，不用带啊。是 y 应该有 m， 只有你最后一个。
What's going on? I wish I understood that.
以你的手指也是，那你长在一个 gradient。你手指就是一个 gradient。因为我发过那个是前好人，现在在发了我的没事没报。
Are you working or talking? Staring. I'm talking on work. Talk fast, talk fast. To get a simple question. Maybe I look at the textbook. I don't want to start with the tough one yet. Okay, so let's do this. One on tangent, one on normal. So 2. Find the equation of the tangent to, let's take something sweet. What do you mean, oh no? The fact that I said sweet doesn't mean it's difficult. Really? Dude, just stop making me look like a bad guy. Krista, do you believe him? When I say sweet question? Miss Sweet? Oh, you're confused. Which Krista? You know, if I do not say Krista, which Krista? Both of you, I'm talking to both of you. Okay? Because it's high time you stop confusing everybody here. Both of you. So try this. It's a very simple one. Please note that the fact that I draw a line here, you can always extend it. Okay? That's still, guys. I'm not saying the normal stops here. It's always perpendicular to the tangent, so it's going to cut across. So that's, I will write that again as x equals to a. So that point remains our x is equal to a. Okay? Let's take note of that. Is this one or two? What?
Do you just write that down? Oh.
So that you don't have this wrong assumption that, oh, normal only stay outside. No, it lives there.
都不用多啊，就这跟上 x 加这个上 x 除以加2 x， x 高了，就这个不是这个，那你可以给我看吗？乘法加哦，它带 x 等于1。负什么？我大概都负。
You want to put together
别当时
yes. That's why we're going to exactly.
Cool. 那长 normal 了。可是也不用那个啦。他演这个就是不是 normal。我全部都在找出来。
I got this.
This will be enough for today.
So, Daniel.
None of the question is here. So keep this. We'll practice this tomorrow. Yes.
Will you check this one?
What question did you do?
That one.
Question 2.
Yeah.
Where does it start? Okay. I don't know how you got your dy dx. I don't know how you got your dy dx.
不要算 tangent。
You need to stop skipping steps because you assume that I know. You need to walk, not just scribble something in your book. Walk the way you will solve it in an exam. Stop writing, oh, final answer. Oh, yeah, you will do it in exam. You get used to it and it will affect you. What number are you doing this?
但是下面这个部分就是那个
3 also? And you? I don't know why they do that, but everyone is
No, I'm just telling you,
Exactly. How's it going? The ladies that confuse us a lot. How's it going, Nick? Why am I even talking to you?
没写题外点。
要
I shouldn't talk to you.
他要我写出我
You
的
do
赛
that?。No, you did not.
所以我这样
You
写
put it here. You didn't do what everybody does, right? Really?
I only wrote this
Okay.
equals this.
哦，我就有写这个。
If you need clue, please talk to me. But whatever you do, please